Probability distribution functions, PDFs. In a game, a 4-sided and a 6-sided dice are rolled together. We can construct a sample space that will show the totals when the individual scores from each dice are added together. The scores on the 6-sided dice could be 1, 2, 3, 4, 5 or 6. The scores on the 4-sided dice could be 1, 2, 3, 4. When added together, the totals range from 2 to 10. From the sample space, we can construct a probability distribution table showing the probability of each score. Little s represents the totals ranging from 2 to 10. P brackets big S equals little s represents the probability of obtaining each of the scores from 2 to 10. The probability of S equals 1 plus the probability of S equals 2 plus the probability of X equals 3 all the way up to the probability of S equals 10 must add up to 1. Example 1. Let X equal the number of heads after 3 flips of a fair coin. Construct a probability distribution function table to represent all outcomes. First thing you need to do is to write down all the possible outcomes when flipping 3 coins. So you could get head, 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 tail, head, tail, head, tail, 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 head, 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 tail, head, tail, head, tail, head, head, or finally tail, tail, tail. So there are 8 possible outcomes. Now we need to draw a probability distribution function table to represent all this data. X represents the number of heads, and you can have no heads, 1 head, 2 heads or 3 heads. Now we can work out the probabilities. The probability that X equals little x. The probability of no heads is 1 out of 8. The probability of 1 head is 3 out of 8. The probability of 2 heads is 3 out of 8, and the probability of 3 heads is 1 out of 8. Writing the probabilities out below, the probability that X equals 1 is 1 out of 8. The probability that X equals 2 is 3 out of 8. The probability that X equals 3 is 1 out of 8, and the probability that X equals 0 is 1 out of 8. Example 2. Hugo plans to buy packs of football cards until he gets the card of his favourite player, but only has enough money to buy 4 packs. Suppose that each pack has the probability of 0.2 of containing the card he wants. Complete the probability distribution function table below. Let X equal the number of packs bought. X could equal 1, 2, 3 or 4 because he has enough money to buy up to 4 packs. We need to find the probability that X equals 3. We know that the probability that X equals 1 is 0.2. The probability that X equals 2 is 0.16. And the probability that X equals 4 is 0.512. We know that the probability that x equals 1 is 0.2. That is given in the question. But is the probability that x equals 2 correct? Let's work it out. The probability that x equals 2 is equal to the probability of not getting the correct card times the probability of getting the correct card. Because on his first pack he may well not get the correct card, but in the second pack he will. And that is equal to 0.8 times 0.2, which when you work it out does come to 0.16. If this is a probability distribution function, these four probabilities must equal 1. So the probability that x equals 1 plus the probability that x equals 2 plus the probability that x equals 3 plus the probability that x equals 4 is equal to 1. Therefore, the probability that x equals 3 is equal to 1 minus 0.2 minus 0.16 minus 0.512, which is equal to 0.128. Question 3. Consider each distribution. Determine if it is a valid probability distribution or not, and explain your answer. In order to be a probability distribution, the probabilities must add up to 1. So A, the probability that x equals 1 plus the probability that x equals 2 plus the probability that x equals 3 must equal 1. Therefore, 0.25 plus 0.60 plus 0.15 equals 1. Therefore, a probability distribution. B. Again, the probability that x equals 0 plus the probability of x equals 1 plus the probability that x equals 2 must equal 1. Therefore, 0.25 plus 0.60 plus 0.20 equals 1.05. Therefore, not a probability distribution.